So in this question, it's asking us which graph represents positive uniform acceleration. What we're looking at here is we're visually representing how we define acceleration. Acceleration in terms of formulas is velocity over time. Okay, so it's how, as time progresses, the velocity changes. Okay, so if you imagine a car slowing down, that's negative acceleration because the velocity is becoming smaller as time goes on. Whereas if you have a car speeding up or a baseball falling off a cliff, the acceleration is positive, like the acceleration of gravity is pulling something down. It's increasing the velocity. So if we think in terms of units, you have meters per second, which is your velocity, divided by seconds, or meters per second squared. So velocity over time, that'd be the slope, right? Because if you think of slope as rise divided by run, your rise in this case is velocity, your run is time. So your slope, m in math, is acceleration. So now let's use that information, that kind of knowledge we've gathered, that acceleration is the slope of a velocity over time graph, to see which of these that makes sense with. Another keyword, they've given us positive acceleration, so we know that the slope will be positive, right? So this has to be a positive value. This has to be a positive, this has to be positive, this has to be positive. It also says uniform. So the slope can't change. So we know we have to have a straight line. Because if you say had a slope, say you've got, 2x plus 1, your slope is 2. You know this from math, that's a linear function. Your slope is 2, as your rise and your run, right? 2 over 1. You know that is constant. It's 2. It's a straight line. It's not curving up or anything like that, anything wacky. It's straight. So we have to first off look at straight lines. So we say right off the bat, nope, not a chance. It's not going to be d, because that's not a straight line. That's a changing acceleration. It's the velocity. Yeah, the velocity is increasing, but it's not increasing at a uniform rate. Now for C, we have the velocity starts high. Let's say it started at 80 or something, for example, and it's dropped down to like 40 at this point. That's decreasing. It's slowing down. There's no way it has a positive acceleration and it's slowing down, so it can't be C. So we're left with these two. Now for B, we have a straight horizontal line. The slope of a straight horizontal line is 0. So how is that positive uniform acceleration? Well, it's uniform. It's not changing. It's 0. It's always 0. But it's not accelerating, so that one doesn't work. This one, on the other hand, is a straight line. The velocity is increasing, as you can see. Say it started at 10 down here and it's up at 90 up here. It's increasing, so that means positive acceleration. It's a straight line. It's uniform, so it must be A.